This is the second video on stoichiometry. We're working off of the same example problems that we were doing in the previous video, right? We did mass to mass. Now we're going to work on the other two types of conversions that you're going to see in your homework. So particles to particles. We've done particles to moles before. Now we're just doing particles of one substance to particles of another. So again, remember that always make sure that you have a balanced equation. In some homework problems, they're going to be balanced already. Others, they're not going to be balanced. So always double check that, and especially on the test and quiz, double check that. So number one, how many formula units of NaCl are needed to react with 4.32 times 10 to the 24th formula units of CaNO3 So we know that we have this 4.32 times 10 to the 24th formula units, right? We're going to convert that into the moles of CaNO3. So we don't need molar mass, right? Because in this case, we want the formula units to cancel out. So in every 1 mole, there is the Avogadro's number, right? 6.02 times 10 to the 23rd formula units. So when that cancels out, right, and you now would take 4.32 times 10 to the 24th divided by 6.02 times 10 to the 23rd, right, that's going to get you the number of moles of your calcium nitrate. Now, when you're punching this in your calculator, be very careful that you're doing it correctly. When you're typing in your values, because you're dividing, it's really important that you take this scientific notation and that you put it in parentheses when you put it in your calculator. Otherwise, it might do the wrong order of operations on you. Okay, so we're in moles of calcium nitrate. So now we're going to do mole to moles, right? Because we need to get into NaCl. Well, for every 1 mole of CaNO3, there's 2 moles of NaCl, right? So our moles of CaNO3 are now canceled out, and if we divide and then multiply, right, divide by the 6.02, multiply by the 2, will now be in moles of sodium chloride, right, or moles of salt. And now we need to get into the formula units of salt. So similar to what we did in this first step, right, but we need moles of NaCl to cancel out. So we need moles of NaCl on the bottom so that they cancel out over on this side, leaving us with the formula units of salt. And there's your answer. Right, so we're going to divide by 6.02 times 10 to the 23rd. We're going to multiply by 6.02 times 10 to the 23rd, and we're going to multiply by 2. Essentially what happens is this cancels this out, and we really just have to multiply by 2, and we'll get the number. Okay, let's do another one. How many molecules of water would form from the reaction of 8.34 times 10 to the 23rd molecules of CH4? So again, the equation's balanced, right? For every 1 mole of CH4, 2 moles of H2O are going to be produced. So starting with what we know, right? 8.34 times 10 to the 23rd molecules of CH, that should be a 4. Somehow it got cut off. Right, we want molecules of CH4 to cancel, so they need to be on the bottom of the fraction. Right, so this cancels out with this. We'll now be in moles of CH4. Now we're going to use that mole ratio. Right, for every 1 mole of CH4, there's 2 moles of H2O. So now our moles of CH4 cancel out, and you're now in moles of water. And then the last step, take the moles of water and go into the molecules. So moles of H2O cancel out with moles of water, and we're left with our molecules of H2O. Again, you're going to do 8.34 times 10 to the 23rd divided by 6.02 times 10 to the 23rd times 2 times 6.02 times 10 to the 23rd, and that will give you your answer. If you some of you will notice that this would cancel out with this, so essentially you could leave that out of your calculator. When you're showing your work, you still have to put it in the problem, even though it cancels out. Your work should look identical to this with the units of measurement, moles and molecules, and the substance listed at the end. And you'll notice that my answer keys are the same way. Okay, next one. Volume to volume. This one is very simple, just like the previous one, except for now we're dealing with a little smaller numbers, right? We don't have to deal with the 6.02 times 10 to the 23rd. So if you remember from the previous unit, let's see here, that for every liter, right, when you do a liter to mole or a volume to mole conversion, that there are 22.4 liters in every mole, regardless of the substance. It's always 22.4 liters in whatever, whether it's a diatomic atom, or it's a polyatomic atom, or it's something that's making a covalent bond or an ionic bond. It doesn't matter. It's always 22.4 liters. So just like before, right, liters of hydrogen are here, so liters of hydrogen have to go on the bottom to cancel out. So now we're in moles of hydrogen. Using the mole-to-mole ratio from the equation, right, for every 3 moles of H2, 2 moles of NH3 are produced. So now moles of hydrogen are on the top, so moles of hydrogen have to be on the bottom to cancel out. And the last one, right, we're in moles of NH3. We want to be in liters of NH3, so moles of NH3 has to be on the bottom, and now we will be in the units of liters, and for the substance, NH3. Again, you might notice here that this volume and this volume could really cancel out, and so if you wanted to, in your calculator, you could hit 2.6 times 2 divided by 3, and that would be it. You'd get your answer. But again, you must write out all of this stuff on a quiz or a test or a homework assignment that you turn in. And if you're not comfortable with that, if you're not sure if these things cancel out or not, then put it all in your calculator. 2.6 divided by 22.4, then multiply by 2, divide by 3, and then multiply by 22.4 again. Last example. How many liters of H2 react with 8.4 liters of N2? So looking at the mole-to-mole relationship, right, for every 1 mole of N2, there's 3 moles of H2. So we're going to take our 8.4 liters of N2, convert it into moles, just like before, right? Liters of N2, that means liters of N2 has to be on the bottom to cancel. We're now going to be in moles of N2, using that mole-to-mole relationship. For every 1 mole of N2, you need 3 moles of H2. So now we are in moles of H2, and then the last step, right, do our moles of H2 back into liters so we can figure out that volume. And again, moles of H2 would cancel, right? They have to be on opposite sides of the fraction, and that gives you your answer of 25 liters. So 8.4 divided by 22.4 times 3 times 22.4 equals 25. Or, again, because these are on opposite sides, they really cancel out also. So 8.4 times 3 gets you 25 liters. If you look back at all of them, don't forget sig figs, right? We had 2 significant figures here, so the answer has 2 significant figures. 2 sig figs here, the answer has 2 sig figs. We've got 3 sig figs here, so the answer has 3 sig figs. And we've got 3 sig figs here, so the answer has 3 sig figs. So don't forget to look at those significant figures. If doing this process that I've been doing here with all of this stuff together in one big equation, if that's confusing for you, consider watching the video that's posted on the site for the class after this, and it really breaks it down. What it does is it makes you do this calculation first, find an answer. Then it makes you do the mole to mole calculation that you've been doing in the first assignment in this unit, and then it makes you do another conversion. So it makes you do these 3 separate steps, finding answers each time, and that might be a little more clear to you or a little easier to you if this process seemed a little bit confusing.